This is the features of graph section from your packet. An independent value is the x value or the input in our function. This means the dependent variable is the y value or the output. When we're looking at graphs, we have two different kinds that we come across. Continuous, this is the kind we can draw without picking up our pencil. So that could be anything that looks nice and smooth for us. It could have ends or arrows, just as long as we can draw without picking up that pencil. The opposite of that is discrete. This is when we have unconnected points that just form a bunch of dots on our graph. All right. Next, we're going to talk about minimum and maximum. And if you recall, there's two different kinds. There is a relative and an absolute. To be a relative maximum or minimum, to be a relative minimum, you're going to be the low compared to the points around you. So this can be multiple. An absolute minimum is going to be the lowest point on the graph. And this is only one. One thing for minimums and maximums that we need to take note of is these are never going to include infinity. So if for some reason infinity is our absolute max or min, we'll just say none for those. So again, these are the same idea for relative max. This is just the high compared to those around it. And for the absolute, it's the highest. So for this class example, first thing we're going to decide is this continuous or discrete. This is continuous because I can draw it all without picking up my pencil. Next, we can determine the relative minimum. So that's any point where this is kind of low on our graph. So I noticed this point right here is low compared to the ones around it. This is the point 1, negative 1. We also have this point here. This is the point 4, 0.5. Notice that we can have multiple relative mins or maxes. Next, a relative max. This is a point that's high compared to the points around it. That could be this point right here. It's like the top of a hill. So this one is the point 3, 1. Absolute minimum. This is the lowest point on our graph. This can be the same as our relative min and max. It's going to be this 1, negative 1 point we used earlier. Then finally, for the absolute max, if we look, I see some arrows, which means that this graph is going to keep going up and up and up, which means it cannot have a maximum because infinity is not a maximum value. Next, when we looked at functions, we can evaluate when given an x value and y value. So first step when given an x value is we're going to plug in the number everywhere we see x. Step 2, once we've plugged it in, we're going to simplify using PEMDAS. So if we take a look at this class example here, mine might have disappeared. Nope, it's right here. Right here, they've given us an x value of 2. So everywhere I see x in this original problem, I'm going to replace it with 2. So here and here. Sorry, here and here. So this is going to become f of 2 equals 5, parenthesis 2 minus 3 plus 1. Then we're going to use PEMDAS to simplify. So recall that PEMDAS stands for parentheses first. So 2 minus 3 gets us -1 in that parentheses. Next up is exponents, which we have none. Remember, that's that tiny little number. Multiplication, anytime we have parentheses, that's multiplying. 5 times -1 is -5. We have no division. We do have addition. -5 plus 1 gets us -4. And since we're all done, let's go take a look at the y values. So back to the previous page, evaluating when given a y value. First step, replace f of x with the number given. So we're going to replace that whole f of x part. We'll see what that looks like in the example. Step 2, you're going to solve for x. So get x all by itself. Recall, we've already done notes on that if you need a refresher. So for this example, since this is set equal to f of x, this is going to replace the f of x here. So we're going to rewrite this as 11 equals 2x minus 1. And now we're just getting x by itself. So I need to get rid of this minus 1 by adding. 11 plus 1 is 12. The 2 and the x are multiplying, so I'm going to divide to get rid of it. 12 divided by 2 is 6.